I will present the project about modeling public transportation attractiveness and system dynamics, the significance of safety perception, that I modeled and wrote in cooperation with Jefferson Raja. And for the context, this was originally an attempt to model public transportation in Los Angeles. So the base of the for the paper originally was this attempt, and the ridership there was declining despite high investments in the local transportation operator Metro, and the city being known for long traffic jams and therefore not really pleasant to drive. So the puzzle therefore was why people would still not use public transportation. And one of the main contributors, according to the literature, right after growing access to cars, was safety feeling. After some research, this turned out to be an important factor, not only in LA, but many more places that, to our knowledge, has not yet been included in system dynamics models covering public transportation. And therefore, we created a conceptual model. So the research purpose is that it is a conceptual model that builds a frame used to inspire modelers to include safety perception, and it intentionally ignores therefore certain aspects in favor of simplicity. And modeling and integrating safety perception in the model, we did that by combining external safety concerns and internal safety measures, and showing its influence on the attractiveness of public transportation. The word safety is often used in different contexts. In this model, it refers to being safe from crime, harassment, or other types of assaults from other people. It does not refer to safety from accidents like crashes. Safety perception is not always based on real threats and is therefore not the same as objectively measured safety. However, it is the more important factor because people decide to use public transportation based on their perception or their feeling and not on some statistics. So the differentiation between these two is important to keep in mind when talking about the indicators for external safety in a moment. External safety refers to external influences on the safety perception outside of the transit and the transit operator's influence. It refers to the general environment and safety feeling in the city. Internal safety measures refer to measures taken inside the transit, on the buses, or at the bus stops. And one thing that is not included in the model, but it is important to mention, is that safety is especially a concern for vulnerable groups. This includes women and elderly, as well as members of the LGBTQ+ community or victims of discrimination and racism. So here you can see part of the model that combines internal measures and external safety indicators into a total indicated safety perception, which feeds into safety perception via an information delay. So transit users only update their perceived safety slowly as they take time to notice when indicators change while using the public transportation. And internal safety measures are safety equipment per bus route as a variable here, because most safety measures such as lights only have a local influence, and therefore the amount of safety equipment that is needed to reach a certain internal safety indicator is based on the size of the bus network, so on the number of bus routes. You can also see that external safety measures are exogenous and cannot be influenced by the transit operators. They can try to take countermeasures by increasing the internal safety, but they cannot really take the problem by its roots. So the external safety indicators that I included here are crime rate and homelessness. The increase in homeless people has been suggested to contribute to the fall in transport ridership in Los Angeles. And public transportation stops and facilities can be used as a shelter from the elements, which makes them attractive for homeless people. However, we want to emphasize that the literature we cited only suggests that homeless people influence perceived fear and discomfort, but not actual incidents. So this shows further the importance to distinguish between safety perception and safety. So while homelessness is a major issue in many cities, there are also other indicators for social problems that influence perceived safety. That could be drug use, but that could also be other things depending on the depicted city. So as it is a conceptual model, this could be adapted for different cities. And for internal safety measures, it is important to know that they can differ largely in installation and operation costs, as well as the effect on perceived safety. So the effect also depends on the type of safety problems or threats that a region faces, that obviously call for different kind of countermeasurements. So therefore, summarizing them all together in one stock is one of the limitations of the model, but also simplification due to this being a conceptual model. But yeah, one can imagine the difference between installing lights and the difference between having security guards on a financial level is very high. So this is definitely one of the simplifications of the model. So next on, I'm showing a simplified causal loop diagram. We developed a stock and flow model that is a bit too large to properly represent here. So the full model can be viewed in the supplementary materials. So at first, the basic transportation model, as many will have seen before similarly somewhere, the revenue generated by public transit users will be used to operate existing bus routes, as well as investing in new lines. And the bus routes, the expansion of bus routes expands the density, or later I will also call that convenience. It's a convenience of using public transportation. So new lines increase the attractiveness of public transportation and therefore attract new users, which lead to more revenue. And this reinforcing loop is balanced by B1, so which indicates the growing expenses that follow from building new routes. So this basic model ignores many aspects such as maintenance costs or subsidies, because it only works as a conceptual frame for introducing safety. However, it is still able to reproduce the behavior that we're looking for. And yeah, it also excludes the comparison of attractiveness with other means of transport, which are usually a very important factor in these types of models. But this could be easily added if you wanted to. So now the full CLD that shows the additional structure that is needed to incorporate safety perception into the model. And it is important to notice that bus routes and safety measures are standing in competition with each other when it comes to resource allocations. So resources are limited and everything can only be invested once. And since public attractiveness depends on both factors and more bus routes lead to a higher need for safety measures, it is important for transit operators to find a good balance of investing in both factors. As the model behavior, as we see in the model simulation later, is driven by two reinforcing loops. So the loop that I explained before and the kind of parallel loop of more resources, more investment in safety measures, higher safety perception, higher public attractiveness, more users, more revenue. Yeah, however, both reinforcing loops are also controlled through the balancing loop, since investment in both bus routes and safety equipment triggers higher operation costs that are prioritized over new investments. So we also did simulation runs, and we developed 3 different scenarios that we analyzed to show how the system reacts to different environments. Our key indicators to compare the results are amount of bus routes and safety measures, as well as public transit attractiveness level and number of public transit users. So here you can already see only in one scenario, the public transit operator can successfully increase attractiveness by increasing both bus routes and safety measures in a proper balance to each other, and leading to a virtuous cycle of attracting more users that leads to increased revenue and increased investment. That stabilizes at some level when all potential users are using public transportation. So let's take a closer look at each scenario and explain why they fail or succeed. So at first, the baseline scenario, which is one of the scenarios where public transit users decline. In this case, I've only included public transit attractiveness, but if the attractiveness is 0, there are also 0 users. So the baseline scenario is set in an environment of normal safety, neither especially high nor low, and low priority for investing in safety measures. This leads to an increase in bus routes and therefore convenience at first, as you can see with the red dotted line. And however, since safety perception drops as a result of low investment and also at the same time an increased network, this leads to a decrease in attractiveness that you can see in the blue line. And this makes people refrain from using public transportation and therefore reduces revenue, which reduces attractiveness even more and leads to a vicious cycle of less money, less investment, less attractiveness. One more thing about safety perception in this graph. So safety perception first goes down because the network expands, and then it goes up again, which is due to an artifact of the simplification that could be reduced with further modeling. So because the bus routes decline so much, the amount of safety equipment per bus routes go up. However, if there's no bus network, you can neither feel safe nor unsafe in it. So it doesn't really make sense that it goes up here. But since it doesn't affect the attractiveness anymore, yeah, this is just an artifact of the simplification. And in scenario 1, you can see the best case development. We have normal external conditions but higher investment into safety measures. Convenience goes up due to new bus routes. Safety perception stays stable. Despite investments, it does not increase because it stands in relationship with the number of bus routes. However, a stable safety feeling is enough as long as attractiveness increases due to the increased convenience and a virtuous cycle of new revenue further investments develops. So this is the scenario that you would aim for as transit operator. And scenario 2 shows that the environment plays a huge role because it has the same priorities for investment as the scenario 1. However, since the external safety is lower, the attractiveness starts out lower than in the previous scenario and is not high enough to trigger growth in the beginning. And then the vicious cycle of less use, less revenue, less investment begins. And this shows the importance of adapting towards the environment. Yeah, so the discussion and results is we concluded when policymakers ignore safety perceptions, the development of ridership numbers could leave them puzzled as they ignore an important influence on the system. So the model is highly sensitive to changes in safety perception. And high attractiveness can only be achieved with both factors, safety perception and convenience. And this leaves 2 points for intervention for policies, which are increase in safety measures and addressing external safety concerns. But this is often not possible for the transit operators and is, yeah, just in general very hard to implement. And the limitations is that this is a conceptual model. It has reduced complexity and it excludes many external factors. Then the aggregation of safety measures in one stock, as I already mentioned, is something that could be improved if you wanted to use the model as more as a conceptual model. And further modeling is necessary to represent the relationship between the number of bus routes and safety measurements better. However, we can still draw some implications for future models, which is that to depict the decision-making processes of public transportation users in a more full, complete way, safety perception is an important factor. And further modeling and adaptation to the depicted region is necessary, but it is also possible to do this loosely based on the conceptual model that we have, at least. And yeah, thank you for your attention.
Awesome. Anybody have questions in the room or online? Oh, that wasn't a hand, that was a clap emoji. All right, Tim.
I'll keep throwing them up there so they have something to respond to. This is really good, and I like that you're looking at transit, because I think it's applicable to many other kinds of large infrastructure, stadiums, things like that, or perceived safety. My question has to do with the boundary selection, where you excluded the external factors. Have you tried just simply testing them to see if a policy intervention on something, even though transit doesn't control it, affects the perception? Because in one way, you may get rid of something to say this wouldn't affect it either way. The other may be the cause is often distant from the effect, and sometimes it may make sense to craft a policy that is more on where the cause is rather than where the symptom appears in the system. So have you done, or are you considering doing a boundary test of those external factors to see if they have any influence?
In the original model, I included some external factors, but the model was also was a lot different from what we have now. So I did not do that yet, as this really was meant more of as inspiration to include this furthermore. And so this is definitely a good point to consider that I should do in the future.
Yes, Charlie.
Hi, thanks, Anna. That was wonderful. I have a question about what you think time frame would be for looking at, if there's, I used to live in California, sometimes infrastructure projects take forever. If there was any, you thought about either trying to add some sort of element of delay of how long it would take for the perceived safety or the lines to come into effect, or if you were looking at some different scenarios that would take place maybe over different lengths of time, or if you had a specific length in time that you had in mind when you were developing this model?
So my model was run over 10 years, I think. But since in this case I was looking at bus routes, I think they are I accounted for a delay for new bus routes, but I think they are a little faster to install in comparison to infrastructure projects that includes like trams or any kind of train related systems. But yeah, the delay is incorporated into the model. It's just I'm not entirely sure how long in reality it takes to plan these type of things, because this was my first project that deals with infrastructure in this way, with transportation.
Okay, thank you so much. This was so wonderful.
Thank you.
Thank you.